Good afternoon, everybody. Thank you so much for joining us today on this very special edition of METALCON Online. Today's very special edition is titled The Architecture of Metal, Designing for Resilience, Beauty, and Performance in Coastal Architecture. We have a fantastic architect presenting with us today, Jeffrey Huber, who has, I think, the entire alphabet after his name, if you can see that on the screen. He is an architect with Brooks and Scrippa, and we are so very excited to have him here presenting this session. Today's session is being presented by Metal Architecture. Metal Architecture has been a fantastic partner of METALCON, and we're so pleased to congratulate them on their 40 years in business. And today I do have Tristan Marks here with me, and he'll give a very brief intro to himself immediately following this. The agenda for today. If you are an architect, please take a close look at the screen here. And this is how you're going to receive your education. These are all of your learning objectives. These are also available on our website. I'm so excited to share with you all that we have dozens of education sessions available completely for free on our website at your convenience. So in case you're looking for continuing education credits, whether it's CEUs through CSI or AIA LUs, please feel free to check out our website. We do have a lot of additional education there. If you're looking for specific products, specific systems, different things like that, we have a lot of information on the website for you as well. So make sure you save that link that's featured right on this page. We're also very excited to let everyone know that the Design District is back at METALCON this year. And at the Design District, we will have a presentation by Brian Zamora, who is a Frank Gehry architect and who designed the Lou Rouveau Center for Brain Sciences and Health in Las Vegas. So a fascinating building and a fascinating discussion. We will also have Minarch discussing fire resilience. And we're so excited to have both of those people at our show. We highly encourage you to register today. I have a very special promo code available on the screen, so make sure you save that for future usage. Also, if anyone needs credits today, whether it's just a certificate of attendance or if you need an actual AIA-LU credit, HSW credit, mind you, you are more than welcome to fill in. We have a brief survey right at the end of this where you just fill in your first name, last name, email address, and that gets you that certificate. So please be sure to fill that out to receive that credit. If you have any further questions, you can always reach out to us, and you can reach out to me directly at kaylin@metalcon.com. Finally, I do want to make sure that if anyone has any technical issues, questions, comments, or concerns, you can reach out in the chat. The chat will be open as well for any questions you may have for our speaker today. So without further ado, I'm going to hand this over to Tristan. Tristan, go ahead and take it away.
Hello, everyone. I'm Tristan Marks, the editor of Metal Architecture magazine, and we are very happy to have on board with us today Jeffrey Huber, and he's going to be talking to us about some very interesting case studies, I believe. Jeff, it's on you.
Thank you. Thank you. Appreciate it. And thanks so much for the introduction, and thank you all for joining us today. Our practice is rooted in designing public places that perform environmentally, socially, and technically. And metal has become one of those most powerful tools on how we do that. And so whether it's a hurricane-resistant park, as I'm going to present today, affordable housing, or custom houses, we use metal not just for durability in the coastal environments, but it's also as an expressive potential, its ability to shape light, texture, and identity. And so today I'll walk you through some of those recent projects where metal has been playing a leading role, and especially in places like Southern California for us, as well as South Florida. And we'll focus in particular on DC Alexander Park, a project that brings together resilience, fabrication, and innovation, as well as a sculptural public space. And so the first project I wanted to highlight was just Cherokee Lofts. It's a pioneering LEED Platinum mixed-use project that reimagines Los Angeles's courtyard apartment typology through a modern lens. And here metal played a central role in both the aesthetic identity as well as the environmental performance of the building itself. Many of the metal components, including its panels, its sculptural or structural supports, were fabricated using recycled aluminum, and this reinforces the project's sustainable ethos, something that's critically important to our firm and practice at Brooks Scarpa. But the building's, again, its most iconic feature is this kind of custom aluminum screen, which wraps the front elevation and provides solar shading to reduce heat gain as well as enhances privacy for units facing the street. The screen is also offset from the building envelope, allowing for a passive ventilation in corridors and units and reducing the need for mechanical cooling. So metal is not just an afterthought, it was a medium for pattern where we get perforation and public identity, expresses the durability and the openness and the protection in urban housing. But most importantly, the metal screen creates this dynamic facade that changes with the light throughout the day and allows users to essentially change the facade. At Animo South, Los Angeles, this is a high school where metal played a critical role in how we shaped both the building's performance as well as its visual identity. We use perforated metal facade screens to reduce solar heat gain again, which allowed us to filter the daylight into classrooms. And these screens also provided privacy for students and enhanced the building's relationship with the surrounding neighborhood through a kind of patterned and textured facade. The material was chosen for its durability in an urban environment, as well as its low maintenance qualities, which were essential for long term stewardship by both the school district and our client. Beyond the aesthetics, the metal elements were integrated into a larger passive ventilation strategy that, again, allowed supporting airflow through exterior corridors, but also through classrooms and contributed to better indoor air quality. Security was another key factor and concern for us. So the metal allowed us to create a protective perimeter without resorting to this kind of fortress-like appearance. And so the screens balance both openness and safety, but also transmitting light while maintaining visibility throughout the campus. And finally, the use of these prefabricated panels also helped accelerate the construction and maintain cost control, offering both precision and efficiency on a very compressed project timeline and budget. Another one of our projects in Los Angeles, Magnolia Apartments, it uses a multi-layered perforated aluminum facade that sparkles in the sun day and glows at night. This acts as a kind of ever-changing screen that shades the building, reducing street noise, but also still lets prevailing breezes, daylight, and views flow through the millions of tiny perforations in some of the perforated metal components. The screen system reappears along the east, west, and north elevations, and its carefully sequenced panels give the exterior walkways a rhythmic texture while filtering both the direct sunlight as well as deepening the project's geometric expression. We wanted these elements in this building to really read the curves, and the metal facades and screens really allowed for us to kind of do just that. And so because these panels are wrapping around the undulating kind of building form, the metal skin doubles duty. It animates the kind of street frontage and protects the outdoor circulation and courtyard spaces from the kind of heat in the central parts of Los Angeles. These prefabricated kind of aluminum panels also provide that precise installation that's quick, and this material's durability and low maintenance finish align with our project's goals of delivering high performance and sustainable housing on a very compact urban infill site. And so, these are just some of those projects in Los Angeles, but moving over to North Carolina, we also have a recently completed single family project called the Chase House, or the Steeplechase, it's also known as, which is metal that it's used to express the home's structural simplicity while delivering both high durability and in a demanding climate. And so this design is defining these two bold gable forms, and then it's clad in this kind of deep black metal skin that unifies the exterior and reinforces the home's strong silhouette against the forest and the kind of natural setting that it's within. This corrugated metal cladding also serves as both an aesthetic and performance goals. It emphasizes a crisp geometry for the house, but it also allows light to play along its folds and seams, and essentially at sunrise and sunset for us, it's a kind of critical material and a kind of critical play on light. So this functionally, it provides both a weather-tight envelope that resists rain, wind, and humidity, which is all critical to a region that's prone with seasonal storms and high moisture levels of this North Carolina, Raleigh area. But the metal also enables these minimal detailing at the eaves and edges. It reinforces the building's clean lines and contemporary rural character. The dark finish also helps the house recede into this wooded lot or the wooded context while still asserting a quiet presence on the landscape for us. And again, here metal does become both armor but also a canvas. And so the wrapping the building in a material that is tough, elegant, and timeless is something that we really want to celebrate and really want to achieve. And that's again what metal and these kind of types of elements give us. And even cats like it. I mean, here's one of the interior views of the house, and you can kind of see how that metal becomes a kind of play, both interior and exterior. At another single family custom home level, this is the Alma Switch House in Manhattan Beach, California, that we just recently completed. And this metal, it's aluminum kind of customized, fabricated, cut panels that are folded and kind of create this brise-soleil facade. But the metal is used as both a performance material and a formal driver. So it's helping us define the home's distinctive coastal presence. It's also situated in a very tight urban lot, just blocks away from the ocean. So the house uses these kind of this metal cladding to create a durable, lightweight envelope that can withstand the kind of corrosive effects of salty air and the coastal weathering as we see it. And so the metal skin wraps around and creates a composition of intersecting volumes. It also kind of accentuates the building's sculptural quality while providing this kind of crisp, almost maintenance-free surface. And so its reflective properties also allow the facade to shift with light and soften the massing despite its bold geometries at different times of the day. And so it's designed with sustainability and longevity in mind. The metal cladding system includes concealed fastening or fasteners and integrated drainage details that ensure the durability of the material itself while preserving a clean aesthetic. And so in this context, metal enables us to look at a modern beach house that feels both industrial but also elegant and resilient, as well as a kind of refined coastal sensibility. The facade's material continues to influence the interior experience as well. So this we place these kind of folded metal panels near overhangs, also screening that modulates daylight and that casts this kind of dappled shadows that move across walls and floors throughout the day for us. And this ephemeral light pattern begins to soften the minimalist interiors, animating spaces that would otherwise could be stark. And so the metal becomes a filter, a controlling glare, creating privacy, but also enriching the home's spatial rhythm through a kind of ever-changing play of light, both day and night. And so the metal is not just a wrapper or a weather barrier for us, it's a mediator between indoors and out. So it's a sculptor of light for us and a tool for both resilience and refinement, all within this kind of tightly scaled urban beach context. It also exemplifies how a simple material can offer a profound spatial and sensory experience when applied with care and intention. And so, where again, these interior and exterior spaces kind of transition, we can remain open while still providing privacy and other elements within a project like this. And so inside, the palette remains restrained. That allows the glow and grain of light filtered through metal to take center stage. And the metal surfaces, often paired with concrete and would provide a high performance yet elegant backdrop that resists, again, wear, moisture, and time. So it's the perfect for us in an active lifestyle for this client that was near the beach. At Angle Lake Station, this is located just south of Seattle and serves as a terminus for Sound Transit's light rail system. Metal is used as both an infrastructural but also an expressive material, transforming a utilitarian transit hub into a dynamic civic landmark. We used the concept of spirographs and ruled geometries that inform the design language that is rooted in motion, precision, and repetition, where complex curves emerge from simple rule-based operations. And these systems allow us to create a dynamic form that feels more like a mathematical, precise, and visually fluid operation. So much like a spirograph, or drawings, or in this case, you see pickup sticks. I mean, these types of drawings that we're also showing reveal the kind of intricate patterns through a rotation of fixed points along rigid paths and ruled geometry that enables us to generate sweeping surfaces with straight lines, emerging elegance with the constructability of this. So the result is a fluid-like surface that reads differently from every angle and constantly shifts throughout the day. We worked a lot with AI and other parametric modeling tools that allow us to generate these parameters and develop a functional, constructible, and simplified screen system, all within the kind of budget of this design build project. So again, we used parametric fabrication tools and custom computational scripts to translate a complex design vision into a system that could be efficiently fabricated and assembled, so the undulating metal skin appeared intricate, but behind its elegance and its rigorous kind of computational framework, this simplified the geometry into a series of repetitive and, again, rule-based components. And so by scripting that logic, the facade's curvature and panelization, we were able to generate this kind of precise fabrication data that directly was able to be transferred from a digital model. And this reduced the kind of tolerance issues and eliminated the need for costly customization for us. And so this was something that was critically important in this project, as well as all these others and the ones I'll be showing. But here's just some of the photos showing that initial installation of some of the pipe columns and beams for the structural elements. What was essentially a standard parking garage of about 1,500 cars that we were looking to get this customized skin, and looking at it in a very affordable, economical, as well as understanding that we had an extreme schedule we had to meet. But the building, again, is wrapped in a series of these rolled aluminum panels that were custom extrusions that then enabled us to achieve both that geometric precision and this kind of visual fluidity. And so here's the custom aluminum extrusion that served as both structure and cladding. And so that dual purpose system minimized additional framing, but also allowed for rapid installation. And because the panels were lightweight, corrosion resistant, and low maintenance, they were ideal for the Pacific Northwest's climate and the near coast environment that this was. And so they were also able to be fabricated, manufactured with a kind of critical timeline and schedule we had. And here you can see the extrusions as well as our happy contractor receiving them prior to their anodization. So they were anodized blue, as you can kind of see here as they were being installed. And so that installation took 4 guys and 2 cherry pickers 2 weeks to put up nearly 1,700 panels. And so this was a huge time saver from that perspective, and really where we like to integrate working with fabricators early on, working with these parametric models, ruled geometries that just simplify this process. And metal as a material really lends itself to that kind of process. So again, these parametrically designed and arranged panels evoke this kind of motion and airflow where they draw inspiration for us from the kind of aircraft or weather patterns and the surrounding environment of the SeaTac airport where this project is near. And so the result is, again, a fluid metallic surface that reads differently from every angle and constantly shifts throughout the day. And here's just an overall kind of looking at that, and you can see the light rail system there on the right-hand side and the overall screen and plaza that are there in the middle ground. So another project for us that we recently completed was at Four Seasons in Westlake Village in California. And so our team designed a series of elegantly sculpted outdoor structures. This one larger structure was one of the key elements, and this extends the resort's wellness and hospitality experience into the landscape and near the pool areas. And so this architecture frames the pool and dining areas through a kind of sequence of steel pipe columns and beams with aluminum angles that provide shelter, shade, and spatial rhythm without obstructing the views of the surrounding hills, as well as really maximizing views back to the pool and other elements. So again, metal was a central part of the design vocabulary in this project. And so it's used not just as its durability in this kind of outdoor setting, but it's also for its precision and ability to convey confinement through a minimal means, where we are taking the ordinary and essentially sculpting it to create something that's more extraordinary within a very tight budget. And every detail had to be carefully considered to balance luxury and restraint, but this was especially exciting to see, as these images show here, old school fabrication techniques that were employed to create these geometries. And it's interesting because we were in fabrication and construction well before we even received the shop drawings on this project, because the engineering firm that was hired on to do the shop drawings was really unable to deal with some of the curves and other complexities. But the fabricator that we had here on the site built all of Disney's roller coasters, and so they had no issues following the geometry with these kind of old school methodologies and means and methods of construction. And so it was quite interesting to work with them. And then we were able to kind of utilize standard aluminum angles, and that we were able to let those curve along some of these elements and bend to create and go along the geometry of the pipe structures itself, ultimately to create, this kind of overall look and feel. And so the choice of these kind of marine grade finishes and hidden fasteners really ensured both aesthetic clarity as well as long-term resilience against sun, humidity, a saline environment, because again, this is near a coastal setting, and it's frequent use. And that was the other thing, is high durability in a client like the Four Seasons that's requiring some of this high performance elements. And so metal, both steel and the aluminum angles, gave us that potential. And so in this project, the metal doesn't overpower, but it refines. It also creates an atmosphere of quiet sophistication, where the durability can meet elegance, and architecture becomes both a frame for leisure, but landscape and for light. So coming to South Florida, we have a whole other set of challenges other than some of the California and North Carolina projects I was just showing. We have these little wind events that you may be aware of that we have. And so in South Florida, we really have some extreme consequences where we're having to deal with 185-mile-per-hour wind loads with 3-second gusts and other elements that really create some serious challenges. And so our firm has been working on methods and solutions for architecture and design for these kind of hot, humid, wind-prone regions that also have the addition of high salinity, as well as being coastal environments and seeing the threat of future sea level rise and other issues and challenges of higher heat. And those related challenges. So this recently published book, Salty Urbanism, it provides our firm with a framework for how we can adapt to both flooding and heat, and it really looks at a showcase of architecture, landscape architecture, and urban design related issues around that. And it looks at materials like metals and how do we begin to think about those and how do they inform our projects in critical ways forward to how we would address future sea level rise, climate change, and other related issues in the South Florida context specifically. But these are contexts that anybody along a coastal environment globally and nationally have to really deal with and reconcile. And so this is the first project I'll present, and it's Youth Sports Complex. And this is in Pompano Beach, Florida, so just north of us here in Fort Lauderdale, where I'm located and based out of. But this is where metal became a medium that through which we could deliver both performance and identity. And so this is not just a recreation facility, it was also a civic anchor in an underserved neighborhood. And so we wanted the architecture to reflect the same values we hold for any major public building, where we needed to ensure durability, dignity, and design excellence. And so this is essentially a billboard building because this surface is about 60 feet across and about 12 feet tall. So, again, one of the most defining elements of the project is this 60-foot by 14-foot custom metal screen that's in the front of the building there, as integrated signage, but it's developed in close collaboration with Eric Small and his team at EES Design Studio. And this is where we really like to work with fabricators, especially the contractor as well as the metal fabricators very early on in these processes. And I'm going to talk a bit more about Eric and his team at EES, but this is where we really wanted to work with them early on to give them our drawings and other elements. But this screen isn't just simply an architectural accent. Again, it's an icon for the project. It provides critical solar shading. It acts as a wind and rain buffer, but it also brings rhythm, scale, and transparency to the building's front facade and signage and wayfinding. It becomes an iconic element along a major throughway along the Pompano Beach corridors. But if you don't know Eric Small and his company EES Design Studio, you should. They build a lot of Alice Aycock sculptures. They do a lot of public art, as you can see in the image here. But they went ahead and fabricated that screen. And so working with EES early on in this process was integral. From the very beginning, we knew we didn't want just an off-the-shelf product. So we were able to, we were able to get something that we could first and foremost, that we had to digitally model, but then we rationalized and then fabricated very efficiently working with EES teams. And so this still felt like a bespoke, but embedded in a kind of sense of place. And one of the challenges that we had as both the architect and the fabricator early on was this project was designed and developed just before COVID. And then it was starting to be constructed during COVID. And so we had to go through some unique, very plausible value engineering changes because we didn't have a dollar extra. This project was funded through a capital improvement project funding. It had about $800,000 to build the building and do this fabrication, which we saw as kind of public art, and we didn't have a dollar more. And so we were able to work with EES and our team at Brooks Scarpa to really understand and kind of take what we had about double the amount of pickets before in this aluminum front skin, and had to kind of work with Eric and his team to really stay within the budget challenges of this project. And so here you're seeing it in his studio, or in their shop being fabricated, and the kind of elements that they do to do that. But here you're also seeing it kind of in the field. So Eric and his in the EES team kind of broke that 60-foot long product into 6 different 10-foot segments, and then you're seeing this kind of video showing the screen as it was both fabricated but also then being installed. And so the engineering was really developed, as well as the fabrication, to resist the corrosion of the South Florida climate. While it did offer the ability to filter again light and create subtle patterns of shadow across the building surfaces, and because these panels were modulated and pre-finished, the system was also very low maintenance, a major plus for us in a public sector client with a tight, again, operational budget. But here you can see some of the images again of that video, and images of the installation itself. But this was a youth sports complex, just to remind you. And so this meant we had kids that would play soccer as well as lacrosse, which would have cleats. And so we wanted to make sure and ensure that this building was highly durable. And so, the front screen and facade use these kind of aluminum pickets and tubes as EES designed and or built and fabricated and installed for us. But we also use PackClad and other products as box rib panels on the building itself. And so here you're just seeing that, how this project kind of reinforced that value of bringing the fabricator in early, but, looking out for the cost of materials, but also shaping the logic of the design itself. And you can see that it has, structural steel elements, as well as a steel roof, as well as again, PackClad steel panels that had to again upstand or or withstand and kind of resist these 185-mile-per-hour wind loads. And so here you're kind of seeing that back kind of drape of the screen, and how it has these kind of curved ruled geometry shapes and elements to it. And so, it's in this youth sports complex, it really is that metal becomes, it doesn't just protect the building, it really does define it with the concrete and metal. And the metal really provides the backdrop to allow us to do these kind of bright colors that we really love to kind of see in our projects. And obviously this case, yellow. And so, it does so, or this architecture does so, through a process that is both bringing together, again, architects, fabricators, and buildings all at the right time in the right place, that are kind of speaking a shared language of design and placemaking, to really create something that's quite unique and spectacular for, the community on a very tight budget. And, I just throw this image in because, we really looked at how we integrated landscape. I'm both an architect and a landscape architect, and so as well as an artist. And so we're always kind of looking at the kind of intricacies of horticulture with art, with architecture, and how these things can kind of be brought in coalescence and synergistic relationships with one another. So, the last project I'm going to really talk through, and I'm going to spend the most amount of time on, is DC Alexander Park. And so, if you don't know South Florida and Fort Lauderdale in particular and Miami region, we began with the very familiar coastal challenge. It's how do we reclaim vulnerable, underperforming land in a way that not only resists climate threats, but climate threats like storm surge, like you see in the image here, and flooding. And we flood 5 different ways, both storm surge. We also flood by high tide flooding. We also flood through pluvial and fluvial flooding, both from rainfall and other events. And so we really wanted to give back to the public realm and begin to achieve more greater resilience and adaptation to coastal threats, and looking at those threats as not actual threats, but as opportunities for how could we design for a more resilient, equitable, and sustainable public realm. And so, this was an image of Hurricane Irma and that storm surge, but this was the aftermath that happened, where you're seeing essentially 2 feet of sand ending up on Beach A1A across the street from the site of DC Alexander Park. And in essence, the city and county had just spent about $8 million renourishing about a 2-mile segment of Fort Lauderdale Beach about 3 months before this. And all that sand ended up being washed up onto Beach A1A. And unfortunately, since it was washed up onto the roadway, it picked up all the hydrocarbons, all the toxins, carcinogens from the kind of built environment. And it all had to be collected and brought to a landfill. So we couldn't just push that sand back to the beach. And a lot of this was because we took away key pieces of ecological infrastructure like dunes and other species. And so we really wanted to look at how could we integrate in DC Alexander Park a rewilding around a coastal uplands kind of landscape, where we reintroduced the dunes, we reintroduced the coastal strand, as well as the maritime hardwood hammock, and looking at how we could integrate those into a site that was highly vulnerable and sees constant effects from sea level, future sea level rise, as well as, again, the coastal flooding, salt spray, heat, corrosion, you name it. This site gets it. And so the site, interestingly enough, was a formerly surface parking lot and turf field. And so it was hard, really uninviting. It created a really uninviting edge, especially between the city and the ocean. And it lacked shade, it lacked identity, it lacked resilience. And so we saw, again, this opportunity to completely reinvent as a new civic landscape what this park could be. And so one that could be both an iconic statement, a durable statement, and deeply rooted in the coastal context of the city of Fort Lauderdale. And so these are just some images that we produced early on, or drawings that we produced to illustrate this kind of idea of how we were going to transform this particular parcel of land. And so you're seeing on the left-hand side the existing park as it was, as a parking lot and a turf grass field. And what we're showing there is kind of the storm surge, how it would come over and how it kind of created those 2 feet of sand coming over onto Beach A1A. And so when you're looking at the image on the right, we're showing how we're proposing this kind of new park that had these upland coastal rewilded elements in it around the dunes. And you're seeing how we could begin to capture and deal with water management, storm surge, and these other elements, and creating a landscape that, we could begin to integrate these concrete forms, as well as this rewilded landscape and a playground elements and a new 25-foot overlook into that beach environment. So the design centers around this kind of sweeping metal canopy and sweeping kind of walkway that moves up, that you see in this kind of oval form on this aerial image of the plan. And so it's where the signature architectural element of the park, that metal canopy, it's not just a structure, it's a marker of arrival, it's a shaded gathering space for us, and it becomes a sculptural form that gives back to the park as a distinct identity. And so, like the rest of the project, it was designed with climate resilience and a kind of public use in mind. And here you can see the canopy along with the series of other metal screen walls, which was developed and fabricated in close collaboration, again, with Eric Small and his EES design studio team and Brooke Scarpa. And the material was carefully selected for its marine grade durability, again, capable of withstanding salt air, wind loads, and long-term exposure without sacrificing the aesthetic clarity. And so this overlook, as you can see, the kind of gentleman up there kind of taking a selfie in that upper right-hand corner, it was this 25-foot overlook that allowed us to have a place to see the best, what we saw best moon rises and sunrises in all of Fort Lauderdale, because that, again, looks eastward. But again, it was a very complex landscape. You're seeing some of these kind of root dunes and how the landscape, again, horticulture, landscape architecture, and the kind of public art all working in tandem and relationship. And so, we worked with another landscape architect team as well as our team of architects and again, metal fabricators and the contractor Shift Construction to really work through this kind of bold project. And again, this was another one that was built recently, completed in last October of 2024. So beyond some of the things that I already talked about, equally important was the way in which the screen and canopy system interact. And so this is just a short video kind of from the beach going back over and looking at how that kind of park situates itself in the environment. But this canopy really does allow for us to cast, again, dappled light across this plaza. It also offers protection from the sun and rain and framing both views towards the ocean and into the park itself. But, again, this park, interesting enough, and another one of our drone videos here, kind of moving from the beach over towards the park, but this ecotone between the water and the land. And so this project is where metal can become both infrastructure and becomes part of the experience for us. And it helped us to define a public space that at once can be elegant, but also tough. And so it was designed to endure the future of climate volatility while inviting people in and providing essentially a public porch to the city and really a family room, if you will, to the city as well, because it has, again, the integrated playground and other features into it. But one of the things I want to kind of start to address and talk on is that, one of the things we found as architects over time is nobody reads drawings. And so a model is worth a million words. And there's not a single straight line in this overlook. So, working with Schiff and their team as contractors and then working with EES as the metal fabricators of those components like the shade canopy and the vanes you see along the side of this form on the right-hand side, this model became something that we used and leveraged and was able to kind of take forward and work through fabrication and construction. It gave us a kind of true knowledge of where we could work directly where actually the true knowledge does lie, and it's with the fabricators who are actually going to be building it and the contractors. And the other thing that we understood is that splines only really work in theory. Our curves had to be rationalized, and we had to look at how that was going to work. And so we had to look at field versus shop drawings, conditions, controlling tolerances. And all of this, even with this curved structure, we found that we were only about a quarter inch off once they actually constructed this. And we learned that through, again, and we're able to achieve that by, again, rationalized complex surfaces where we were still understanding how to build or how this project would be built. But it's all about how this kind of team came together in a collaborative nature to really see this. And so here you're seeing, again, a model of that canopy on the left-hand side. But we also did a lot of RTK site scanning, and the contractor did a lot of this. And that's how they were able to achieve and understand and linking up our digital model with the real world and through a kind of augmented reality of understanding this process through this project, which made it much easier to communicate with our exhibits, our models, our drawings, and seeing real world kind of challenges. And so these models are really useful. And so all we do is we say to a lot of our other architect friends, just share the models. Make sure those models are very robust and can be linked with directly with fabricators as well as our contractors. And so there's so much more to see once you have these kind of models, especially when you have unique geometries and where, again, that architecture is a spatial field. So when we are looking at most of our drawings, they're flattening them into documents of what is essentially an untold or an unfolding of these objects. And so, again, having these 3D BIM models and these other models that could serve as digital twins for us was really something that was quite important, as well as the RTK scanning and getting that information and underlaying it with our technical drawings to ensure, we had the accuracy that we did when you don't have these kind of luxury of straight lines in these projects. And so, again, being off by only a quarter inch was a pretty amazing feat in and of itself for, I think, our team, the contractor, fabricator, and, our design team and engineering team. And so, I throw this slide up because, real world fabrication and cost restrictions do require us to think about rationalizing our designs we propose. So different elements are produced with different tools and environments, and we can't change the way that we produce things. So in order to produce good design, we as the architect have to work within the constraints that we're given. And how do we rationalize geometries and again explain something like a spline that works well in theory, but you really have to kind of show like that left-hand side spline line. How does that get rationalized? What is the kind of radii and those kind of information and segmenting that in a way that can easily be fabricated and built? And so, Eric and EES and his team really created some of what we thought were the most beautiful shop drawings we've ever seen for some of the elements on this project, specifically the shade canopy. And this was just some of the drawings that they were producing. But what I wanted to kind of point out here is that the bottom layer is really showing you a steel kind of castellated frame and beam system that really lightened up the weight of the structure. And you could think steel on a coastal setting with high salinity was a huge effort, but that's where we had to we hot dip galvanized everything and really worked through the connections. And then it was clamshelled with that second layer, which is an aluminum skin and veins and other elements that began to clad this. And so you'll see some of that end or finished geometry and images of the canopy here shortly. But other drawings that they simplifying the process, and we again formed this kind of true collaboration with the fabricator and in through our design and engineering team to really explain and simplify and understand the kind of means and methods of the tolerances of the metals that we were looking at, and how we could even think about rolling the tolerances of rolling a already fabricated I-beam. Because again, it was a city project, a municipal project done for the city of Fort Lauderdale. So we didn't have a lot of be able to use customized elements. Even though this is a highly customized fabricated piece, we still had to use W shapes and other things. We couldn't just use flat steel and then weld them and fabricate these kind of custom elements. We had to kind of work within those tolerances. And so it was again a real critical need to link us with our fabrication and design and engineering teams and the contractor to understand the tolerances of the materials. So getting back to the main structure, I also want to touch that, the metals that we considered into this. I mean, every single element, even the concrete, we used galvanized reinforcement, steel reinforcement. We looked at using alternatives like fiberglass and basalt, but they're not really up to the level of needing, especially when you're looking at curved geometries like this. You're looking at a lot of specialized needs, but also the Florida Building Code doesn't really allow us to use these for robust structures that are within this kind of coastal area. So we're using galvanized steel reinforcement in the concrete, ensuring that we have the 3 inches of minimum coverage, but we're also integrating things like Zypex or Penetron into that concrete that really make it impregnable to saltwater corrosion and intrusion into the concrete mass. And so, this was coming around the same time as the Surfside Champlain South Tower collapse that happened in Surfside, Florida, just north of Miami Beach in the Miami region. And so these were challenges. We want this project to be durable, resilient, and we want it to last more than 50 years in its design life. And so that was, again, some of those critical challenges and why we really looked at that galvanized reinforcement and rebar. These kind of curved geometries and structures, as you're seeing here, is basically a Varendale truss on both sides of this overlook, and how all of this kind of integrated with the galvanized steel structure and concrete formwork to really create, again, thinking about the fact that we were only off by a quarter inch between our drawings and what was actually the built condition, again, was a testament to the contractor as well as the fabricator on this team. And so here you're just seeing some of the visuals of that overlook as it was being constructed just before we began to add on the canopy and other elements. But we also worked with Radius Track and other fabricators for the underbelly of this overlook, and other miscellaneous components and elements like guardrails and handrails were also integrated into this project. But Radius Track, we were able to create double curvature properties. And so here you're seeing the images in blue, or the blue elements are the kind of aluminum frames of the radius track system that allowed us to have essentially a scaffolding to then put Dens glass and other cementitious board up and stucco elements to create this kind of smooth overlook element. And so here you're seeing how they're able to, through kerfing and other technologies, get some of this kind of double curvature in the system. And there you're seeing some of that being even installed into the underbelly of this overlook. And so, again, we went with aluminum because it's a highly corrosive environment. But, aluminum unfortunately couldn't be used for things like elements in the canopy, except for some of the perforated metal and cladding systems. The main structure had to be steel just because of, again, the flexure and other things to resist 185 mile per hour wind loads. And it's interesting because it's not necessarily the weight of these materials and everything, it's the uplift on these materials that create a lot of challenges for us. And where, even that column you're seeing kind of there on the left-hand side, the concrete column, was essentially there to hold up part of that cantilever, but it was also there to hold and hold down the canopy from being ripped out potentially during a 185 mile per hour or more wind event. And so back to the canopy, you can see here how we had to bridge our design drawings with Eric and his team to create these shop drawings. And here's just some of the columns, as well as each, even down to the level of the bolts and how we kind of created those was Eric and EES team, really kind of looking and understanding how these kind of components move through our project and our design, and how we were specifying them to again achieve the most resilient and durable project we could. And so here you're just seeing some images of how these columns for the canopy come down. There on the right hand side is actually the the actual column foundation itself and how it ties in, and that eventually got a slab topping layer over that, so it hides that base plate. But you can see this is all hot dip galvanized steel. You can see the wall thickness in there, and then these are just sleeved over with the columns for the canopy like you see on the left-hand side, and then basically bolted together with stainless steel connections. Here you can see the canopy as it was being fabricated in the EES shop. And so, the architect and engineering team, as well as the contractor, was constantly going over there and looking at it. But you can see some of the steel castellated beams that are in there that you saw from that shop drawing, and then some of the veins and other clamshell aluminum cladding kind of coming around this. And then just some of those kind of drawings that the EES team produced. And then this is how they were coming out of the paint booths and shops, and then ultimately to the site and being installed. And this thing erected and was installed pretty quickly. And so here, we thought it was going to come out in pieces, but the EES team really brought it out as almost an erector set. And so they hoisted these beams. You're seeing all of those kind of got placed in and fabricated, or at least installed in the field in a matter of a week. We had a pretty finalized canopy system. And so ultimately at the end of the day, you're seeing some of that perforated metal veining for the shade canopy structure, a kind of overview of that canopy looking back down towards that overlook and that 25-foot cantilevered kind of element there. And just some of the other images, recent images we have of this project. And so you can again see how the kind of metal canopy creates this kind of dappled light and playfulness on that left-hand side image, but also on the right-hand side image really shows how this became a kind of iconic element and really a statement piece and a kind of public art where the sculpture and the form really served us well. And so from the north facade looking south, you can see again the kind of canopy and some of these metal veins, perforated metal screen that was on that front facade, and how that kind of works through. And even as you're kind of approaching that 25-foot overlook back towards the ocean there, you can see in the background, but just how that canopy and the cladding, the aluminum and the steel kind of columns, tube columns, come down to really create this kind of elegance and the sculptural kind of form and frame. And then, here again at the overlook, just, how it creates what the city was asking for, which was this kind of Instagram moment. And so, with that, I'm going to go ahead and close this out, and I'm happy to open up to questions and answers. But, just a little bit about us, Brooks Scarpa. Again, we're headquartered out in Los Angeles, Florida, but we have an office here in Fort Lauderdale and Miami. And these are just some of the books we have available if anybody's interested. And with that, thank you.
Amazing. I'm going to bring in our special panelist. Here we go.
Yeah, I made sure we had Eric here just in case any technical questions. So thank you, Eric, for joining us.
Yeah, glad to be a part of this. It was an incredible presentation. Thank you.
Thank you for being here. Okay. So we did have a few questions for you, Jeff. Tristan, did you want to start off with the
Yeah,
first?
sure thing. Again, thank you so much, Jeff, for the presentation. That was both really fascinating to look at and also very informative.
Thank you.
So given you've done a lot of work, as you were mentioning, in the Florida area, you have to deal with that corrosive, well, salty urbanism, to use your title there. How do you determine what metals to use? You mentioned aluminum, but you also mentioned aluminum is not necessarily the best metal in some circumstances.
Yes, it's always we start with kind of an environmental mapping where we look at salt exposure zones, humidity, UV intensity, like you just mentioned, the wind loading, all these kind of effects do kind of pair. And we're also pairing that with life cycle cost analysis because a lot of our projects are public projects, and sometimes we have to use or look at the taxpayers' best, bang for their buck. And so how do we kind of do that? But, most aluminum alloys and stainless steel are obviously our top choices when it comes to it because they're less corrosive or they're more resilient to the extreme environments that we're most often working in. But we also, have to sometimes go down to mild steel as well as, whether it be 316 or other forms of stainless steel, we may have to kind of look at that. And then we start to look at the coatings, powder coating, anodization, which I know I presented some of those. And I'm sure, Eric, you may be able to touch on like what we did at DC Alexander Park, because I know those were pretty much marine grade finishes. Eric and his team, kind of brought us to the painting booths and the painter that he uses a lot. And the guy was showing us like what they use for the Alice Aycock sculptures, and that these in some places are in Abu Dhabi in the desert on a coastal environment. And they've been sitting there for 25 years. And so obviously when you hear those kind of things, those are obviously stories that we understand. And so it's always a kind of mapping that we look at and how we're going to assess that. It's environmental, but it's social, but it's also economic. So we're always looking at that kind of triple bottom line of sustainability to really understand when we use what where. And so I don't know, Eric, if you have any other comment to provide specific maybe to your thoughts on it, because you work in this environment every day. So
Yeah, it's usually, it depends on the design. There was a piece that we did for Coral Gables a few years ago that the artist required, it's almost like a spider type flower. And, in nature, a spider has a very small leg at the bottom that gets bigger and bigger to the body. But then, like in actual, engineering, that it's kind of the opposite. You want bigger at the bottom. So we had to, choose specialty types of stainless. Like in this case in particular, it's called Aquamet, which is like a yacht propeller shaft stainless steel material that we had to, do like a specialty welding. So it's site specific, project specific. In the case of DC Alexander, we had to use a 10-inch double extra strong pipe that was rolled, and we could only get that in steel. And we had it rolled by an outfit out of Chicago. It has a big roller, and being steel, it on the ocean, we had to just be extra safe that everything was well protected. So we decided to hot dip galvanize as well as zinc prime and an intermediate primer and an industrial PPG top coat. So it's completely sealed, and it'll last for 60 plus years in that situation.
and it
So
was not segmented, right, too, Eric, right? This is one solid piece pipe from top to bottom. So
yeah, yeah, it was yeah, big pipe. And then I think the biggest I-beam that was hot dip galvanized was like almost 50 feet. So that we had, we had it hot dip galvanized in a company in Miami that had a large tank, but it wasn't large enough. So they had to double dip it. They had to dip one side in and then dip the other side in and then just make sure everything was good. And, hot dip galvanizing, that's certified. That's all on highway signage. It's all over the place. And it's, that's certified over 60, 80 years, I think, as well. So, we take an okay. Also, the powder coater that I use, he's been in business for over 40 years, and he's just like a wealth of knowledge as far as he's already been through every issue and has resolved every issue. And having all that knowledge gives us a big head start in making sure we coat these things properly so they can last.
So speaking of building in Florida, this is, I guess, more of a question for Jeff. Do you have any experience with structure designs for insulated metal panel buildings in the state of Florida?
We SIP panels, structural insulated panels, we've kind of avoided somewhat. Especially down here in South Florida. It's not to say that, I've looked at them. It's just economically, they're not as easy to use. Ironically here, because of the 185 mile per hour wind loads that we're dealing with sometimes, and we've kind of explored a lot of options. I've seen them used, and I have used them up in St. Augustine a lot and other areas, but just down here where we have a regulatory landscape and authorities having jurisdiction, sometimes they want to see every single element. And that's why, we do a lot of prefabricated out in California, using kind of SIPs or even like, kind of the ones that are clad with wood. It's just, it depends. It's just our environment here, the extreme environment in South Florida. We just haven't been too much using that for especially commercial buildings. I have seen it used in single family construction, and we just don't do a lot of single family construction down here in South Florida just yet. But I'm looking more and more, ironically, at things potentially like that. But yeah.
Now, another question which might be good for both of you, maybe more on Eric's end, when it comes to you know, fabricating those large metal elements and using different kinds of steel in a corrosive environment, is there a specific gauge of metal that's ideal, you find?
That boils down to, the wind load requirements and then the engineer's calculations. So in the DC Alexander case, the 10-inch pipe with the half-inch wall, it's called a double extra strong wall. Then the 24-inch I-beam was specified by the engineer for like the thickness, web thickness, wall
Right.
thickness, and all that. And there's also, we get material data sheets from our suppliers to find out the actual KSI, the yield strength of the material, which that's a factor. Sometimes you can get a higher yield strength on material with you can go with a thinner wall thickness, but it's ultimately up to the engineer and their load requirements.
Now, another question that came in through the chat here. In reference to the first few projects that you showed us, Jeff, the metal
Right.
panels that created shade and lighting effects, what software do you use to create those panels?
I mean, we use a lot of Rhino and Revit, and so in Rhino, we have Grasshopper and other plug-in tools that allow us to look at these kind of parametric design. Every project, and I didn't show, some of our public art, and I know Eric knows this piece that we did out in Pembroke Pine, but we always start with sketches. It's always a sketch, and then we kind of go in and we're exploring the ideas through Rhinoceros. I know Eric uses SolidWorks, I think, right, Eric? And,
Yep.
that's kind of like our Revit tool, but Rhinoceros allows us to explore and iterate quickly and in a very fast way by exploring those ideas. So, it all starts with an idea, and again, that kind of gets plugged into Rhino, and then we can use things like Grasshopper to kind of script things that allow us to modulate or look at different patterns or look at different, so a lot of those projects that we were showing, even the DC Alexander project that Eric worked on, a lot of the form and the shapes and everything was modeled through Rhinoceros and Grasshopper and looking to find those kind of forms. So it was a kind of a form finding kind of exercise that we used through Rhino.
So I think we have enough time for just one more question, you think?
Sure.
Okay. Um, so important question here. how do you see the role of metal evolving in architecture? Especially like when it comes to climate change. I mean, we saw the example from DC Alexander with that huge storm that rolled in with the and blew the beach up into the park.
Yeah, no, I mean, as climate events become, more frequent and severe, to be durable, adaptable, and low maintenance materials. Because again, I always love this. Like clients always ask us for can we have it no maintenance? And I'm like, there's no such thing as no maintenance. There's only low maintenance. So materials, like metal will become essential because of that. Because metal, again, offers that durability, that adaptability, that low maintenance kind of element. You just have to be very cognizant about corrosion and other issues on coastal environments. And that's where, again, we just were talking about mapping these things out. If I know I have the budget for this, then, we can kind of explore different opportunities. But metal is poetic. It allows us to bend, twist, shimmer. It allows us to do a lot of different things that you couldn't do otherwise with other kind of materials. And so again, it's an ideal material to both address climate crisis as well as a kind of cultural need for an expressive material that we can use in a lot of these public spaces, but also within our private projects and with our private clients.
Well, thank you very much, Jeff and Eric.
Thank you.
That was a very fantastic seminar.
Well, thank you. And thank you, Eric, for joining. Yeah, appreciate it.
Yeah, you're welcome. Happy to be a part of this. Thank you for giving us such credit. I really appreciate it.
Yes.
Well, thank you, Tristan. Thank you, Kaylin. Yeah.
Thank you guys so much for being here. Jeff, thank you so much for your insights and your fantastic project presentation today. Eric, thank you for jumping on and being a part of our big Q&A today. Tristan, thank you so much for being my amazing co-host. I really appreciate that. And thank you to everyone who's here with us today, who watched live and who's watching in the future on YouTube. For anyone who wants to share this with their with fellow architects or other individuals at their firms, this will be available later on today at roughly 4 p.m. on YouTube. So feel free to check this out on the METALCON YouTube channel. If you have any further questions regarding this topic, you can reach out to METALCON and we will make sure that gets over into the right individual's hands. Again, as soon as this is over, you're going to see a very quick pop-up on your screen for your continuing education credits or for your certificate of attendance. We so appreciate you all being here today. We look forward to seeing you in the next one. Thanks, everyone.
Thank you. Thank you.
Bye.
Thank you.
Bye.
Bye-bye.
Bye, everyone.